Let's look at the fundamental counting principle, also known as the multiplication principle. Suppose you have 5 shirts and 3 pairs of pants. How many different outfits are possible? Let's say these are your 5 shirts. You've got a TIU shirt, Trinity shirt, a white t-shirt, a Bulls shirt, a Cubs shirt, and a flannel shirt. Now for each of those 5 shirts, you have 3 pairs of pants. So for example, with that TIU shirt, you could wear your jeans, your dress pants, or your shorts. And actually, that's true of each of your 5 shirts. With each of those 5 shirts, you have 3 different possibilities for pants: jeans, dress, and shorts. So in other words, you have 5 times 3, in other words, 15 outfits. 5 shirts and then 3 pairs of pants for each of those 5 shirts. Now suppose you have 5 shirts, 3 pairs of pants, and 20 baseball caps. How many different outfits are possible? Well, the answer is no longer 5 times 3. Oh my goodness! You are just rolling in the outfits. You have 5 times 3 times 20. In other words, 300 outfits. More generally, the fundamental counting principle, or the multiplication rule, goes like this. Suppose we have a multi-step process in which step 1 has n1 possible outcomes. Step 2 has n2 possible outcomes, etc., all the way down to step k, which has n sub k possible outcomes. Then the entire process has n1 times n2 ... times n sub k possible outcomes. So let's take this example. We have a 3-step process. Choose your shirt, choose your pants, choose your baseball caps. How many different outcomes are possible? 5 ways to choose the shirt, 3 ways to choose the pants, 20 ways to choose the baseball cap. They're 5 times 3 times 20. In other words, 300 different outfits. Suppose we go to Baskin-Robbins 31 flavors to buy a triple scoop ice cream cone. How many triple scoop ice cream cones are possible if you choose 3 different flavors and order matters? This, for example, looks like it's blueberry and cherry and pistachio, and maybe the order really matters to you. Well, here's the way to solve this problem. In how many ways can you choose that first flavor, that top flavor? There are 31. There are 31 ways you can choose that top flavor. It appears that you've chosen blueberry. Now, having chosen that first flavor, in how many ways can you choose the second flavor? There are only 30 ways, because it's not 31, because you are choosing 3 different flavors. You've already chosen blueberry. You can't get blueberry for that second flavor. It's got to be something else. So you've chosen, I guess, cherry. And then in how many ways can you choose the third flavor? There are only 29, because you can't choose blueberry or cherry for that third flavor. You've got to choose something else. You've chosen pistachio. So again, fundamental counting principle. Step 1 is n1 outcomes, step 2 is n2 outcomes, etc. The entire process is n1 times n2, etc. possible outcomes. In this case, there are 31 outcomes for step 1, 30 outcomes at step 2, 29 possible outcomes at step 3, so the total number of different outcomes overall is 31 times 30 times 29, which is 26,970 ice cream cones. Many Illinois license plates consist of 3 letters followed by 4 numerals. How many such license plates are possible? Well, here's what they look like. Letter, 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 number, 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 number. Okay, so here would be an example. When you're doing these problems, the best way to do it is just to come up with an example. Just one example just to start off. So let's make TIU 1995. Okay, 1995 was the year I started teaching at TIU. There are 26 ways you can choose that first letter. So the first step in the process, 26 different outcomes. Now how many ways can you choose that second letter? 26. You might be thinking, whoa, no, it's 25. There are only 25 ways you can choose that second letter. No, this problem is different. In the ice cream problem, you had to choose different flavors of ice cream. Here, there's no such limitation. You've already chosen one letter. You can use that letter again for the second letter. That's fine. And in the same way, there are 26 ways to choose that third letter. Now, as for the numbers, there are 10 ways to choose that first number, 10 ways to choose the second number, 10 ways to choose the third number, 10 ways to choose the fourth number. So overall, there are 175,760,000 different license plates.